Alright, in order to start out, in a previous recording I mentioned that for exponents you have the 0.5 here, which of course is 1/2. That, by the laws of exponents, becomes the second root or the square root of a number, which I'm sharing here. This is basically saying the same thing. 1/2 for an exponent is the square root. I'm going to show you that. Google, by the way, is pretty good. Pretty good calculator. So 9 to the 1/2 power, the square root of 9 is 3, and there it is. That's the same as the square root. I can also rewrite this as SQRT 9, and there it is again, 3. There we go. While you can do quite a bit with the Google calculator, I also do like you to use a handheld scientific calculator. This one here is a graphing calculator, by the way. That's the only one I have on my desktop here. So you don't have to go out that much to buy this one, but I'm just going to share this one because that's what I have available. Alright, I'm going to go almost back to this one here. So in the previous recording, once we analyzed the Desmos data, we came up with that y equals around 2 times x to the 0.5, respectively the square root of that. And that is the pendulum equation, which I'm sharing right here, so that t equals 2 pi square root of L over G. So this is basically the same as, give me a moment, I have to figure out how my pen on my desktop here. So that's basically the same thing as t equals 2 pi times the square root of the length over gravity, the g that we had. And remember, I rounded this one here to a 2. It was quite close here, but if I take this part here and this part here, 2 pi divided by the square root of g, and type that into the calculator. So 2 times pi divide by the square root, let's see, there's the square root of 9.81, that's what we did in the experiment in the previous recording. I come up with 2.006, so the 2 that I rounded here was close enough, but it wasn't exact, because apparently it is 2 pi divided by the square root of 6. By the way, when you use Google for pi, that is 2 times pi right there, and it recognizes that 2 times 3.14 and so on. Right, that means that the equation we had in the previous recording, this one right here, from the parameters from the regression analysis, is the same as t equals where does this come in here? I don't want this here. There we go. T equals rounded 2, this one is, times the square root of L. Alright, so this project here, I'm going to get rid of these little dots there. This project here is quite similar to what we did previously. I reset this one here. I'm going to get to 0.10 meters and so on. And accidentally, in the previous one, I left this at 9.81, which was fine. It didn't matter to what I was going to do anyway. Today I'm going to change it to 9.82 that we actually do have in Alaska. I like you to do that too. Turn on the period timer again, and this time around, don't go with these small angles where we got these really nice results on the regression curve, but go with any kind of angle you want. So large here, and then change the angle from one to the next. So for example, here is the one for 0.10 meters, 0.7073. This drives me a little crazy, so I'm going to stop this one. And then in Desmos, I would like you to use the same one we did previously. So I'm going to start here with a table, the same link that is, and you can just add on here. So there's a second table here, and we have data of 0.10 meters. And let's see, I have that short-term memory, 0.7073. There we go. 0.07073. By the way, you probably noticed that I've been writing the 0 at the end here. And this is important because if I don't do this, 0.1, 0.2, it seems like this is a little inaccurate. It seems like a rounded number, but when we write 0.010, 0.10, 0.20, and so on, it says, oh, this is rather accurate. It's accurate to 2 decimals or 2 significant figures, and that's how it was. This one here is that accurate, so that 0 here actually is important. By the way, we never touched the mass here. If we did, then these 2 zeros here also would be important. All right, back to this one. So here we're going to have a new table. I'm going to get a couple more data here, and then I'll let you do that. So 0.20, so again, relatively large angle. And some of them I might make smaller, so 0.9342, again, I have to remember that. So here we go. And I don't remember that. 0.9342. Did I get it? Yes. There we go, there we go. Okay, so here come the data points. What I'm going to do now is I'm going to change the color for this one here. There we go. And maybe I want to also make them a little bigger. Whoa, what happened? I try this again. So I hold this down here, and then I'm going to make them a little bigger here, and then I'm going to make maybe X's out of that. There we go. And if I really wanted to have the other curve not interfere with that, all I have to do is click once, and that's gone. Click once, and that's gone. But they're not deleted. They're still there. So I could nicely turn them back on. Okay? So either way, you can hide them or you can leave them on. I'm going to take one more data point here. So at 0.30, oh, I have to actually let it swing. There we go. 1.1104. 1.1104. Should type that first. It's just easier to remember that way. And there we go. And then, of course, we do a regression curve for this, a model. So I'm going to have, in this case here, y2. That's our new data set here. The tilde sign, which is proportional to, again, we're going to use an m times, and then x2. Again, that's the parameters here, or the variables in the table. And then plus the b, we're able to use the same parameters as before, so we can just keep the m and the b in here, but of course we have to change the y2 and the x2 here. And yes, it doesn't look too bad as a straight line here, but you're going to get more data, and we kind of know from the previous one with the small angles that, yeah, we're going to get that curve there with the exponent being approximately 0.5 or the square root. And so I might as well put that in here. So I'm going to go 1 over here, and now I'm going to do the caret symbol, and again I'm going to put an unknown exponent in there. It looks really nice. I'm also going to like to change the color to keep it the same here, so I hold this down here with the mouse, and then I click on this orange one, and there are the data. What I like you to do now is to continue all the way up to 1.00 here, measure the period, and put these in the decimals graph. Here you may use the first three I made, or you make your own. And I think my instructions are hopefully clear enough. Just go to the next one here, 0.40, hit the period timer. Oh, let it swing whatever large or small angle you want, rather a large one, to get new data, and then see what you come up with in the Desmos analysis. So that's it. So this time you have to do more yourself.